All right. Unit 1 is rigid transformations, and Unit 2 goes into dilations and slope, but I just lumped it together, rigid and non-rigid transformations. So a translation means to slide. To move an object without turning or flipping is to slide it left, right, up, down, diagonal without turning. So maybe orientation doesn't change. Reflection, just like a mirror, is to mirror or to flip. Rotation is to turn. A dilation is to increase or decrease an image. So to change size. But not change size proportionately. Proportion. I don't even know how to spell that. Proportionately. Enlargement, to get bigger. Reduction, to get smaller. To get to get smaller. We have 4 different types of transformations. Number 1, RA is here, and then it slides down here. So that means that's a translation. Next, we're here. It's facing one way, and then it's facing the opposite way. This is a reflection. Here, our image was here, and it turned up here, so this is a rotation. Goes from big to small, means it's a dilation, and it's reduced in size. Where do you see transformations in the real world? List of examples below. So translations, reflections, rotations, and dilations. You should have 2 on your paper. I'm not going to give you any. You should come up with 2 on your own. Next, translate triangle ABC, 5 units left, 2 units down. Then answer A through C. Okay, so I'm going to translate it 5 units left and 2 units down. So this would be A prime. Next, B, 1, 2, 3, 4, 5, 1, 2. And then C, 1, 2, 3, 4, 5, 1, 2. And then we can connect our points, drawing the best straight lines we can to connect them. Record the vertices of the pre-image and the image in the table below. Vertice is just a point, so it's ordered paired. So A is at 2, 4. B is at 6, 7. And C is at 7, 3. A prime, B prime, C prime. So A prime is -3, +2. B is at 1, 5. And C is at 2, 1. This is where you might have a little bit of differ in what you say. Describe how the transformation affected the x and y values. So my x value, what is happening? It goes from 2 to -3. You can say a lot of different things. You can go as simple as the value, it's decreasing. And then y goes from 4 to 2. So again, we are decreasing. How could you summarize the effect of the transformation algebraically? So our ordered pairs are an x comma y. My x is decreasing, so it's subtraction. What are we decreasing by? Well, it was 2, and it went to -3. It was 6 and went to 1. That one's a little bit easier to see. 6 take away 5. And then y we said was also decreasing. It went from 3 to 1. It decreased by 2. This also tells you left is to subtract on a number line. Moving down is also to subtract on a number line. And then this tells me how many units. Next, use the translation GHIJ to answer A through C. Give a verbal description of the translation. It should be written, but that's okay. So let's go from I to I. So I, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 left. One, two, three, 4. And 4 units up. How would you represent the translation algebraically? So like this. So x, y. My x went left, so that means take away 7. My y went up. Going up means increasing, and it was 4. What do you notice about the line, segment, and angle measures in the pre-image and the image? Well, did any of my angle measures change? Or did any of my line segments change? None of them did. So you would say all angles and line segments stayed the same. Seg. I don't know what I was putting there, sorry. Next, reflecting. Reflect X, Y, Z over the Y axis. Axes. So this is Y right here. So we're going to go from here to here. 1, 2, 1, 2. Remember, your image stays the same distance away from your axes. So here it's 2 away, so I'm going to go 2 away. Do the same thing here, and then X is 7 away. So this would be W prime, Y prime, and X prime. W, X, Y, W prime, Y, X prime, and Y prime. So W, ordered pair is 2, 6. Y is X, sorry. X is 7, 4. And Y was 2, 2. For my image, W is -2, 6. X is -7, 4. And Y is -2, 2. Describe how the reflection affected the X and Y values. Did my Y values change at all? I have 6, 4, 2, 6, 4, 2. So my y values stayed the same. My x values, it was 2, the negative 2, 7, the negative 7, 2, and negative 2. So they became their opposites. How would you represent the reflection algebraically? So when you have a reflection, your ordered pair would look something like this, where our originals were x, y. They were both positive. Both numbers are positive. And then our image, our x's became negative, and our y's stayed the same. That shows us that our x's are opposites and y's are the same. Next, we have reflect JKL over the x-axis and record the coordinates of the image below. So here's my x. So K was 2 away, gonna go 2 away. L was 1, 2, 3 away, so I'm gonna go 3 away. J is 7 away, so I'm gonna go 7 away. So this is K, L, J. So my prime is negative 7, 7. Is my ordered pair. K is negative 5, 2. And L is negative 2, 3. Originally, I had a negative and a negative. These are both negatives down here. K was also negative and a negative. And L was also negative and a negative. I could put the numbers in there, but we don't need those right now. We just need to know what were the signs. So algebraically, my original was negative x, negative y. And now I have negative x and positive y. So that's how we would describe it algebraically. ABC was rotated. Well, clockwise goes this way. Blank units degrees clockwise or blank units counterclockwise. Okay. So ABC. It's here. This is my, so that's clockwise. That means 90 degrees because there's only one turn. And the opposite of 90 degrees when you are in a circle would be 270. And we can prove it by, here's my center of rotation. Here's one turn, two turn, three turn. And I got it, put it back over the image. Complete the table. So we have A, B, C, A prime, B prime, C prime. Originals are up here. So A was 2, 3. B is 5, 8. And C is 6, 1. A prime is 3, 2, negative 2. 3, negative 2. B is 8, negative 5. And C is 1, negative 6. Describe how the rotation affected the values of the ordered pairs. Well, x's are still positive. My y's are negative, though. So that could be 1. X's remained positive and y's became negative. Write an algebraic rule for the rotation. So we start with our original. Our originals are both positive, so x, comma, y. And we have to determine what is happening. Sorry. Okay, so we have 2, 3 and 3, 2. 2, 3, 3, 2. So they switched. My x became my y, but negative. And my y became my x. So it would be y and then a negative x. Because then that's true here too. My x became the y position. Because your normal is x, comma, y. So they flip-flopped, and then our x's became negative. A rotation can be represented by the rule. X, comma, y becomes y, comma, negative x, which we just determined that was true up here. So true. In this case, it was negative x, comma, y, and it became y, comma, x, because my x's were negative and they became positive. So the rotation. So this one, no. So this one actually would be false. Because this rotation is the opposite of this one. Because we flipped over the y. The rotation rotated 90 degrees clockwise. So we started here. We're 1 quadrant over. So that means that is true. The figure was rotated from quadrant 1 to quadrant 2. Well, this is quadrant 1. This is my image. This is quadrant 2. So this one is false. So this one makes it true here. That's how we make that one true. This statement we need to rewrite. Right. The figure was rotated from quadrant 2 to quadrant 1. Next. Scale factor. Scale factor is a ratio. Can also say a fraction. Because a fraction and a ratio are written the same. So here's our ratio. It's either new over original. New is the image of something. And pre-image is the original. The scale factor is, if the scale factor is greater than 1, it will enlarge in size. Multiplying something by a number bigger than 1, it's going to become a bigger number. If the scale factor is less, I don't need to write then, less than 1, it will reduce. If you multiply something by a half, it will get smaller. A dilation is a transformation that will either increase or decrease the size of the original figure. Increase or decrease the size of an original figure by the given scale factor. To dilate a figure, multiply its dimensions by the scale factor. Gotta do some math here. So we need to figure out what are the new dimensions of our rectangle. This is less than 1, so it got smaller, and that's why I drew a small one. So scale factor is 2/5. So that means I'm going to have 15 times 2, and then it's a fifth. But we can do 15 times 2. Step by step is 30. Divided by 5 gives us 6. Okay, now we have 35 times 2, all divided by 5. 35 times 2 is 70. And 70 divided by 5 is 14. Okay, next. Scale factor is 3.5, so that means this one's going to be bigger because 3.5 is greater than 1. 22 times 3.5. 22 times 3.5. 77. 10 times 3.5 is 35. Scale factor is 5/3. That means it's greater than 1 because I have 5/3. That means I have a whole and then part of 1. I have all of this one and then part of 1. So I'm going to have 9 times 5 all divided by 3. Well, 9 times 5 is 45. 45 divided by 3 is 15. And then I have 30 times 5 divided by 3. 30 times 5 is 150. Yeah, 150. 30 times 5. 150. Divided by 3 should be 50. 50. So when you do scale factor, you are just multiplying every single number by whatever your scale factor might be. When you are finding scale factor, that's when these ratios come in hand. So my new length, my prime, divided by its corresponding side, 8. You can reduce this, and it would be 5/4. Next, new and its corresponding side. And you can simplify that to 2/3. I would not divide them, do 12 divided by 18. Man. Because that's 0.666666667. This one would be a nicer number. 2 point something. No, 1 point something. 10 divided by 8. 1 1/4. So it's just easier to keep them as their fraction. Last page of this set, this unit. So dilate A, B, C, D by a scale factor of 2. So first let's figure out what are all of our points. A is -2, 1. B is 2, 1. C is 2, -1. And D is -2, -1. Scale factor means to multiply. So I'm going to multiply every single one of these numbers by 2. -2 times 2 is -4. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. 2 times 2 is 4. 2 times -1 is -2. And -2 times 2 is -4. And then -2. Our algebraic rule would be 2 times x and 2 times y. Multiplied every single number by 2. And then we can replot it. You could also, if this was over 2 up 1, you can do it 2 times. So 1, 2. It's going to be 2 times bigger. Whoops, I drew that line in the wrong spot. -4, -2, -4, +2. They all line up. For this one, I think I've seen the most trouble here because 2/3 isn't as nice of a number. So you're first going to want to get your ordered pairs. So E is 3, 3. F is 3, 9. And G is 9, 3. If I multiply every single number by 2/3, I would have, I break it up into steps. So I do 3 times 2, which is 6. Divide that by 3. And here's my 2/3. You could write as 3 times 2 divided by 3. You would do the top and then the bottom. 3 times 2 is 6. Divided by 3 is 2. So we have 2, 2. Any number 3 is going to be a 2. 9. I'm going to have 9 times 2, all divided by 3. So 9 times 2 is 18. 18 divided by 3 is 6. Our algebraic rule would be 2/3 times x and 2/3 times y, because every single number we multiply by 2/3. Congruent means same shape, same size. Angles and segments don't change. Similar mean same shape. This one needs to say shape and size. I forgot. So same size, same shape. Same shape, different size. Angles are the same. So if they're similar, it means it's been dilated. It's been dilated by a scale factor, so that means your shape is going to get smaller. So like this one, this was this new triangle where it's the same shape, it's just a different size. So they're similar because they're the same, but they're different sizes. So on number 4, would these be the same, similar shapes or congruent shapes? They're in different locations, different orientation. This one's been rotated. But all their measures are the same. So these would be congruent. These have 90-degree angles. They're different sizes. Different size proportionately. So this was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now it's 2. So that was 3 times smaller. 1, 2, 3, 4. And that's 3 times smaller. So similar. And the scale factor would be 3 because this is our prime, or this is our original, this is our new. All of our original lengths are multiplied by 3, and they are now the same. That is it for this one. There will be another video for Unit 2, and I'll probably do a Unit 2 and Unit 3 video together.